Okay, hello everyone. So today is our second lesson of electricity. Okay, so let's move into the first part. It's called potential difference. So last time we have introduced what is a potential difference in a circuit, right? We consider the circuit as like a kind of river, right? We regarded the power supply, or you can also say battery, as a pump, right? And the pump can make the water from the very low places to a very high places, and then make a loop. So for potential difference, it's just like a height difference in the circuit. So let's move into this part, please. Okay. So like here, we said that the battery is like a pump, right? So you're just pumping the lower water to a higher places, right? Like this way, okay? So if the potential difference of the battery is 1.5 voltage, then we can say it's just like here on the negative terminal is 0 meter for the river, okay? Here the water level is 0 meter. Maybe here the water level is 1.5 meter, right? And we all know that the water just flows from the highest point to the lower point, right? So it's from 1.5 meter, then moving to next part, moving, and then moving to 0 meter, like this height, right? So this is for the battery. And then maybe you can calculate for here 1.5 voltage for the battery, and they can move in a loop, okay? They can form a loop. And for the lamp, because it has to consume the energy and maybe it has to transfer the electricity into the light, right? So here it consumes energy, and that is like a very big stone block in the way, right? And like here, maybe it's like a full of the water, and here's a big stone in them, okay? So maybe here it just consumes energy. So here it's just like 1.5 meter, and after the lamp, it goes to 0 meter. And the potential difference means that it takes in some voltage, or like takes in some energy of electricity, okay? Like this way. And also to remember that there is a principle for this. That is just one single like wire, like this way. Maybe we can draw like this way. Like a purple line is a one single wire. There's never a cross, just a straight wire, okay? And we can set right there, and it's the same height, like for the river. So maybe for the current, we can set it have the same potential. Like here, it's 1.5 meter, and here is 1.5 meter. So if you regard it as the voltage is 1.5 voltage, and here's 1.5 voltage, they're equal to each other. And also you can find on the right, there are also a wire connected into two parts, right? There's no cross. They're just a very straight wire, okay? So like 0 meter and 0 meter. So we can say here there's a height difference between the battery. Like it is a pump, right? It's a water pump. So on the left of the battery, on the right of the battery, they have the difference, or like potential difference of 1.5 voltage. And for the lamp, right here, it also has 1.5 voltage and maybe 1.5 meter, okay? So if you want to measure it, you have to using like this, using a voltmeter to detect the potential difference, or like as like a height difference gauge, and they're trying to measure the height difference between two places in a river, like this way. Okay, so it must connect it to two places of the in the river. Okay, like this way. So here is also like when you want to measure the potential difference of the lamp, you also have to use a voltmeter on the two part of the lamp. Okay, so we can set here. Oh, the voltage or potential difference for filament lamp is 1.5 voltage. Okay, I think it's very easy for you, right? Okay, so here is what in the lab we are using the voltmeter to measure. Like here we can find, you can connect the wire on the voltmeter like this way, and here the black connects with the negative terminal, and the red connects with the positive terminal, and just current flows from the positive and then flows out from the black right here. Okay, and then it can deflect like this way, and we can read the readings on the voltmeter and find the potential difference right here. Okay. And also to remember, here is a new word called electromotive force. We call it EMF, okay? And EMF, that as most of the time, is used just on a very single cell, okay? But you can use a word to describe a very single cell. This is for the potential difference, or like the voltage across the cell, okay? So maybe here is a example. Like we have like for these four cells connected together. And here it is 1.5 voltage, 1.5 voltage, 1.5 voltage, and there's also 1.5 voltage. So you can just consider there are four pumps connected together. If the lowest point is 0 meter, and here it must be 1.5 meter, and here it must be 3 meter, because it's just pumps up, right? And here is 4.5 meter, and here is 6 meter, right? So we can say on the left and the right, there has a height difference of 6 meter, right? So this is for the height. And maybe for voltage, there are just 6 voltage, right? So we can say right here, the potential difference equals to 6, just equals or just similar to the height difference right here, okay? So we can say this means the potential difference for 4 cells or for a very big battery, right? And if you want to describe the electromotive force, like EMF of a cell, or like a single cell, you can only describe for one cell. So you can say right here, the electromotive force for one cell is 1.5 voltage. For most of the time, you cannot using the electromotive force to describe the total battery. So you cannot say, oh, the total electromotive force for battery 6, this is false, okay? So please remember that only electromotive force can describe a very single cell, okay? The difference. Okay, so let's move into exercise for today's our lesson, please. Okay, so can you tell me how to connect amper or ammeter and voltmeter in the circuit, please? Okay. Okay, so I guess you have your answer, right? For ammeter, we said before, it's just like measuring the water speed in the river, right? So it must connected in the center of the river. So in the circuit, we can say it just connected in the center on of the wire, or like the center of the circuit. Okay, so here is ammeter or ammeter right here. And for voltmeter, we said, oh, it just want to measure the potential difference maybe for a resistor or like a battery. So maybe here you can connect it here, or maybe here you can connect in this place. Okay, so they are both correct. Maybe here for D is correct, right? Ammeter must connect it in the center of the wire, and the voltmeter must be parallel with the component you want to measure, right? Okay, so we choose D. You can find C is not correct because V is in the center, is not correct. And here, V center is correct, but A must be the center of the wire, okay, like this way, center of the wire. And maybe here you maybe have a question. So, teacher Mai Lin, I'm wondering why here ammeter is truly at the center, okay? But you using your finger to point from the positive terminal like this way, like here you're using your finger to point here and just moving through like this way. And to remember that ammeter is just like a wire. It doesn't have any resistance, okay? So maybe the current just like a very naughty boy. It just wants to become very lazy and very fluently. So we can say, oh, just travels like this way, and this way, okay? And just from positive terminal to negative terminal, okay? So just flows like this way. So we can say here is we're choosing B. If we're choosing B, that you can find the circuit just block the resistor and the voltmeter, okay? So we cannot use B. The final answer is D, okay? Okay, so today is our lesson, so see you next time. Bye.